Hello and welcome to the reteaching similar questions that are like your reteaching, that are like your quizzes, that are like your tests. First one, simplify. It just has a root in the bottom. It just has a root. We don't want the root in the bottom, so we multiply by whatever exactly is on bottom. So in this case, the square root of 2 over the square root of 2. Because when you take the square root times the exact same thing, that will cancel out. So this becomes 9 square root 2 because you're multiplying across. Square root 2 times square root 2 is the square root of 4. And you can reduce that. And that would become just 2. Just 2. That'd be your answer for that first one. Second one. If you look here, I'm adding and subtracting. So this is different. This is different than if I were multiplying. In the 6.2 video, we show you how to change all your radicals. So this would be a cubic root, or your roots. Root and radicals are the same thing. Into, let me think for a second, fraction exponents. But when we have adding and subtracting here, we don't want to have a fraction exponent because that won't help us with the adding and subtracting. So I'm doing this, I'm going to do my prime factorization. I have 27 and I have 10. This will give me 9 and 3, 3 and 3, 2 and 5. This one could be 64 and 10. This could be 8 times 8. This could be 2 times 4, not 4 times 4. A lot of people do that. 2 and 2, 2 and 2, 2 and 5. So a little bit different here because my index here is 3. When I'm simplifying these, I'm looking for groups of 3. So this 4 is still on the outside. I'm not doing anything with that 4. That's where that came from. Now I'm looking for groups of 3. So I'm going to circle 1, 1, 2, 3. Cross 2 out because I'm looking for groups of 3. Neither of these are groups of 3, so those have the same side. So anything that's circled comes out. I like to think of it as it's a balloon and it's floating out of there. Anything that's circled is a balloon, it's floating out of there. Anything that's left inside stays inside. So this is the cubic root. So I have to have that little 3 there because it started with the cubic root of 10. And then I'm going to simplify my second one. And let's see here. I am going to 1, 2, 3. 1, 2, 3. Okay. These do not have any pairs, so those have to stay inside. So this 2 comes out right here. This 2 is circled, so that floats on out of there. This 2 is circled, so that floats on here. And what's left inside is this 2 and this 5. So if I simplify this again, this is 4 times 3, so this is 12. Cubic root of 10. Subtract, I forgot my cube there. 2 times 2 times 2 would give me 8. And this is also a cubic root of 10 because this is 2 times 5 because this is 2 times 5. So now since these are the exact same, these roots are the exact same right here. Both are cubic roots of 10. Then I can just do 12 subtract 8. And so 12 subtract 8 would give me 4. And that would be of the cubic root of 10. So that would be my answer for that second one. Next. I can make this a little bit smaller because I might need some more room. So it looks like I have a parentheses and a parentheses and it's multiplying in between. Whenever you see this, it's multiplying in between. You should be thinking first, outside, inside, last. First, outside, inside, last. First, outside, inside, last. So you're multiplying here. First would give me 80. My outside, so this 8 is not in a root, so that gets multiplied with the 5. So this would be a positive number because it's a positive 8 times a positive 5 would be 40. And you still have a square root 5 there. Inside, so right here, oops, actually this 2 and this 10 should get multiplied together because those are both on the outside. And, oopsie daisies, this is a negative 2 times 10, so that's a negative 20 square root 5. And my last. So this 2 and 5 get multiplied together. So negative 2 times positive 5 will give me a negative 10. And then I have a square root 5 times square root 5. So these two When I multiply my two last together, I'm multiplying the negative 2 times 5, that's where I get the negative 10. And the square root of 5 times the square root of 5 is the square root of 25, because you can multiply those two together. So now I'm going to simplify this. So one thing I'm going to do, so I'm going to rewrite this. This is like negative 10 times 5, because the square root of 25 is just 5. And if I multiply those together, that would be 10 times 5 is 50. Okay, so this is what I have right now. 80 plus 40 square root of 5, subtract 20 square root of 5, minus 50. So I'm going to do my like terms. Both of these have square root of 5, so I can combine those together, and both of these are numbers, so I can combine those together. 80 minus 50 would give me 30, and since these are both square root 5 and a square root 5, I can do this subtraction. So it's 40 subtract 20, so it would be negative 20 square root 5, and that would be my answer for that one. Last one, rationalizing the denominator. So, I'm actually just going to go like this. When you're rationalizing the denominator and you have a root, you cannot have a root in a denominator. And the reason simply is it's harder to compare like numbers. So if you're having a long problem and if you have a radical in the bottom of a fraction, you're not sure if you can combine numbers because some numbers are in the top of the fraction, some are at the bottom. So I need to rationalize this. We don't want to multiply by the conjugate. In order to find the conjugate, you always look in the denominator. And in the conjugate, it's the same numbers. So these are my same numbers. And it should be the same numbers on top and bottom because you're going to be multiplying by 1. So it has to be the same fraction. And then you look in this denominator. And whatever this shows, the other one is the opposite. So this is adding for both. So I would put these in parentheses. So on top, I would distribute this 2. So on top, this becomes 14, and this becomes 6 square root 11, because the 2 gets multiplied by the 7 and the 3. On bottom, it's your first